All right, question 25. For this particular question, we already know the resistance of an aluminum wire is 17 degrees, or sorry, 17 ohms at 20 degrees Celsius. So what we're looking for this time is what the resistance of that conductor is going to be now that the temperature has gone up to 90 degrees. So what we need to know for that is we need to know the concept of positive temperature coefficient. So what that is that the resistance of a material, if it has a positive temperature coefficient, if the resistance or if the temperature goes up, the resistance is going to go up as well. That's if it's positive. And all conductors have a positive temperature coefficient, whereas we just learned in electronics that semiconductors actually have a negative temperature coefficient. Where the temperature goes up, the resistance is going to go down. And that's going to cause problems in electronic circuits. Example that we talked about in class is the positive temperature coefficient of tungsten. It's got a very large positive temperature coefficient. So if you measure a light bulb when it's cold, it's going to have a very low, relatively low resistance. But as soon as you turn that light bulb on, because incandescent lamps burn so hot, the resistance is going to skyrocket because it does have a very high temperature coefficient. And this is what makes it so hard to measure the resistive values in a circuit that incorporates incandescent lighting, because it changes drastically with temperature. Either way, we're going to use a formula that we've learned in module A1, and that is the resistance change equals our original resistance times the temperature coefficient, symbolized by an A, times the change in temperature. And the delta, the triangle here, represents change. So now we just got to plug in our formula here. Our original resistance is 17. Our temperature coefficient of aluminum is 0.0039. And so that 0.0039 represents the change per degree that the temperature goes up. So the resistance is going to go up by 0.0039. And the change in temperature is the difference between 90 and 20, so 70 degrees. That's going to give us a resistance change of 4.641 ohms. Now we got to be careful here because that's not what the question is asking. We're not looking for resistance, the change of resistance. We're looking at what is the resistance of that wire now at 90 degrees. So this is where we got to use, and this is a bit of an intuitive formula, but where our new resistance is going to be equal to the original resistance plus the resistance change. So that's going to be 17, which is our original, plus 4.641, and that's going to give us 21.64 ohms.